And we need to start by listing the givens. The first given, well, I don't know about your opinion, right? But in my opinion, it's a lot better now than last year. So I have a first given is the type of lens. It is a divergent lens. Okay, that's the first step. The second step, the focal, which is 20 centimeters. It's asking you to find the image distance. Unknown, okay? And in part A, which is the only part that I'm going to be doing, because the rest you will do it, in part A, they are giving you an object's position at 40 centimeters. So P, forty centimeters. So they're asking you to find the image distance. Image distance, remember, is Q, what you're going to look for. And because we're talking about divergent lens, remember these are the negative lenses, which means that the focal length is going to be negative. Remember, sorry. First step, mirror equation to isolate for Q. So we say that 1 over Q is equal to 1 over F minus 1 over P. Remember, focal is negative. So we say that 1 over Q is equal to 1 over 20, but negative, okay, minus 1 over 40. How much is this as a fraction? How much is this?
Miss, I got -3 over 40.
Exactly. Now, reciprocal function in each side will give you Q equals negative 13.33 centimeters. That is the first step. Second step, magnification. These kind of exercises, the good thing about it is that the formula won't change. The formula is not going to change. And specifically for divergent lens, the ray diagram is not going to vary from the one I gave you the other day. So the magnification is equal to negative Q over P. Substitute by the values that we obtained from the step before will be negative 13.33. Take a look. This negative is from the formula. And the negative 13.33 comes from Q. Okay? Negative divided by P, which is 40 centimeters. The magnification is how much?
Miss, 0.33325.
333 would be enough. Okay? So what can we say about the magnification? How is the image that is going to be formed? Virtual or real?
Virtual.
Virtual image. Upright or inverted? Upright or upside down?
Upright.
upright image, and 0.33 is less than 1. The image is going to be larger or smaller.
Smaller.
Smaller than object, than real object. Now, 40 and 20, the two values that we need to sketch are quite large numbers, so we need to use a scale. What scale do you think we can use for the ray diagram? This is the data that we have. We have P, which is 40, and we have F, which is 20 centimeters. What scale can we use for these two numbers? We can use the scale of 5, 1. That would be perfect, in my opinion. So we say divided by 5, which is going to give you 8 centimeters, and the F divided by 5 is going to give you 4 centimeters, or to be boxes. Okay, that depends on the kind of notebook that you have. So first step, sketching the principal axis like this. Second step, your y-axis. No, así no era, ¿verdad? Sí, sí era. Now the y-axis, ¿qué dice? No lo sé, Rick. I don't know what I did. This is too bold. No, it's fine. Okay. Now in that point, right in the center, I will make the sketch of my divergent lens. The divergent lens, remember, it's the one that is thinner in the center. Okay. So my divergent lens will look something like this. Espérense. Bueno, más o menos. Bueno, sort of. Okay. Now, because we already decided, guys, when I do the sketch, I really hope you are doing it on your notebook too. Are you exactly following me in the notebook?
Me, yes.
Yes?
Yes.
Okay. Bueno. So, this point right here in the center, remember that is an important point. We say that the focal is going to be 4 centimeters. So for me, For me, okay, I'm gonna be using 2 boxes for each centimeter, okay? You can use 1 if you prefer. 1, 2, 3, and 4. Here is 1 focal for me, and in the other side, I'm also gonna have the other focal. Remember, I'm using a scale 5-1. Okay. Hermoso, ¿no? I don't have an issue on that. I just move it. Charles. Okay. So I was saying for 5, 6, 7, 8. So my object, this point at 8 is going to be my P, my point P. At 4, I'm going to have my focal. And at the other 4, I'm going to have the other focal. Because my object, I'm going to place it at P. This side where P is going to be my front side. Therefore, the other side will be the back, like that. So it doesn't say what kind of object, it just says an object is placed. So I'm gonna do a regular object. I could use you could use a coin, a 50-cent coin to draw a round object, or you can draw a box. I'm gonna draw a box this time. A rectangular box. A better square. I don't know why, but I like squares better. Remember that I place the object right in the center, okay? Right in the center. So my center of the square object is right here. How do I know this is the center? Because this is the place where the 2 diagonals intersect. So that point is the center, okay? So this is the center of my object, and my rays are going to be projected from the top of my object, center top of my object, right there, okay? Now, the sketch that we need to follow is the one that I sent you to the group the other day, which is this one, okay? So, in this one, remember, the first ray from the top of the object horizontally to the center y-axis, and then it turns back to the focal point in front of the object. Okay, so that's exactly what I'm gonna do. The first ray in red pen or red color, straight horizontally to the center axis, to the center x-axis, y-axis, sorry. Take a look. This is my lens, but that ray comes right here to the y-axis. So here, you need to be careful on that part, okay? It is to the y-axis, and then it comes back like this, passing through the focal point. Remember that here as a dashed line. So this is your first ray. Okay? Now the second ray comes from the top of the object until the other focal point in the back. But the point where it touches the y-axis, then you will sketch a straight horizontal line. Okay? So that is the part of the ray 2. That one I do it in blue. Okay, so the reason why I color the box is because I want that it looks different than the lens. That's why. Okay, that's why I use a different color, but it doesn't really matter. So right now, my ray comes from the top of my object until the focal point in the back over there. Now, in this point, are you following me? In this point,
Yes, miss.
okay, good. In this point, you will sketch a horizontal line. Okay, a horizontal line. Okay, and in the front, do it as a dash line. That is my second ray. Okay, and now the third ray, let's see. The third ray comes from the top of the object, passing through the center of the two axes. The third ray, I do it in green pen. If you don't have a green pen, you can use a green color. If you have nothing green, use another color. But try to not repeat the colors that we use in the rays. Remember, it passes through the center, like that. I think, okay, okay, yeah. Now, the point where the three lines intersect, as you can see, is right here. So in that place, you're going to locate the image. The image, I will do it in a different color, okay? Different than all the colors. And it's good that you write, that you indicate that this is the image and the other object is actually the object, like that. And with this, you sketch that ray diagram, and then you compare if it makes sense. It says that magnification is 0.333, which means that is virtual, upright, and smaller. As you can see, it's upright because it's above the x-axis and it's smaller than the real object. So we say that it makes sense. Now let's see the position of the image. Okay, the position of the image in numbers is 13.33. Okay, 13.33. La tengo mal ubicada. Wait a second. Está un poquito mal ubicada. I need to move it. Pero no voy a poder. Bueno, aquí. Sí puedo. Ahí sí. Okay. Now, as you can see the position of the image, if I project the center of this object, will be here, the center of the object. Okay? And remember that each box represents 5 centimeters. So here I have 5 centimeters up to here. Here I have 10. Here I have 15. So it is between 10 and 15. Okay? Closer to 15 than 10. So it makes sense because it fits the information that we obtained in numbers, which was 13.33. So with this, we can say that we confirm the answer that we got, and the sketch is going to be correct. Now, it is not necessary that you check if you did it right, but if you have the time to check it, do it. Okay, it's very useful. I usually just trust my instinct and I say, nah, it's good. Nah, it makes sense. And it's true, it makes sense. Okay, so right now, I know that you have just 40 minutes, but start working on the part B, okay? Start working on part B. So in the part B, you're gonna have the same divergent lens, but the thing that changes is the position of the object. Now it's not 40 centimeters, now it's just 20, okay? So work on B and C as part of the homework for you to study for the quiz that we're gonna be doing on Wednesday. Remember tomorrow quiz, chemistry quiz. So work in part B and C. Yes, it's gonna come this topic. The last two topics, okay? What are the last two topics in physics? Diverging and converging lens. Converging lens, I already did a review, okay? Remember? Now this was convex. Converging lens, this is the review that I gave you on June 14. The exercise about the pencil that here no image was formed. But I also did another example, this one, okay? Remember that for converging lenses we use we use these conditions, okay, this table for conditions. So I'm gonna send this to you. To the group to have it with you, okay? Ay, no la puedo enviar. It doesn't allow me to send it, but I know